Hello everyone, welcome back to my channel, Master Computer Science subject. In this video, we are going to discuss about the construction of simple LR parser with a given grammar, a very simple grammar I have taken. So to construct LR parser, it involves in fact three steps. First step is we need to construct LR0 automaton. Second step, we need to build SLR parsing table. After the parsing table is built, using the parsing table, it is possible to parse the given string. So we are going to do all these three steps in this video, right? Before that, let us recollect what is LR parser. LR parser is one of the bottom-up parser. The first L stands for left to right scan and R means rightmost derivation, that too in reverse order. Okay, before getting into the problem, I want to give explanation for one more concept also. Just look into these production rules. And I have kept a dot also. A derives dot xy. Here A derives x dot y. A derives xy dot. So what is the meaning of this? If the dot is at the leftmost end on the right hand side of the production rule, it means the parser is at to parse x, or the parser is yet to see the strings which are derivable from x. Okay, look into the next production rule. In this case, the parser has seen x. Now it is hoping to see the strings which are derivable from y. Okay, look into the last case. Here the dot is available at the rightmost end. Whenever there is a production rule which has a dot at the rightmost end, it means now the rule is ready for reduction. It means xy can be reduced to a. That is the meaning. So please keep the steps as in mind. And now let us begin the construction of LR0 automaton. So we are going to construct LR0 automaton. From the name automaton itself, we know that we are going to construct a transition diagram, right? So what is the initial state of this LR0 automaton? Initial state of the LR0 automaton is the augmented grammar. Grammar is available here, so we have to know what is augmented grammar. Augmented grammar is nothing but including a new production rule. Let it begin with a variable s dash, and this s dash derives s. S is the current start symbol of the grammar, and I keep the dot at the leftmost end, indicating that none of the rules are parsed by the LR parser right now, right? S dash derives dot s. It means the next non-terminal symbol what parser is looking for is s. So what I have to do, I have to include the production rules for s, whichever is given in the grammar. So what is given in the grammar here? S derives dd. So let me include that. S derives dot dd. Now in this production rule, you see again dot is available at the leftmost end. After dot, what non-terminal appears? D appears. So include the production rule for D. So D derives AD and D derives dot D. In both cases, after a dot, since terminal appears, there is nothing more to add here. This is the start state of the LR0 automaton. I will call this state as I0. The meaning of I0 is item set. It is a collection of so many items like this. Normally in the start state, we have the augmented grammar. It begins like this. You have a new start symbol s dash that should derive the current start symbol of the grammar. So after a dot, you just check whether it is a terminal or non-terminal. If it is a non-terminal, include the rules for non-terminal. If it is a terminal, further there are no rules to include. Okay, now we found the start state of the LR0 automata. Now we have to continue constructing the transition diagram. So how do we continue constructing the transition diagram? So from the state, I can give a input on yes. It means if the parser reads yes, after the dot, whatever the symbol is there, that is the symbol parser is looking for. So if it reads yes, what happens? If it reads this D, what is going to happen? If it reads the terminal A, what will happen? If it reads the terminal D, what is going to happen? So if it reads S, after reading S, the S is kept at the end. Once the dot has come at the rightmost end of the production rule, further there is nothing more to do with the production rule. Right? So let me call the state as I1. Because after dot there is no non-terminal. If there is a non-terminal appears, I can include the production rules for that. So there is nothing to do in this case. Okay. Now from the state on reading D, what happens? So this is a rule which has a D after the dot, right? So reading the D, S derives, it has read the first D and the dot position is shifted here. At the next moment, it is hoping to see the strings derivable from this D. It means I have to include the production rules of D. So what are the production rules we have? D derives dot AD, D derives dot D. When you are including the production rules based on the non-terminal, make sure that in the production rules, the dot should be available at the leftmost end. Right. So after including the production rules, there is no non-terminal after the dot. So that's it. This state we have identified. We can call the state as I2. On reading A. So which is the production rule is having A at the next moment. This is the production rule. D derives A dot D. Alright. So after a dot there is a non-terminal. It means we have to include the production rules of D. So what are the production rules we have for D? This rule as well as this rule. We have to include as it is. So D derives dot AD, D derives dot D. So let us call it as a state I3. Now from the state I0 on reading the symbol D, what is the change happening? D derives, the D is shifted to the rightmost end. Further, there are no rules to be added in this state. Let us call this state as I4. Right. The transition diagram is over? No, not at over. So from the state I1, further there is nothing to continue because the dot is at the rightmost end. But from I2, I can continue transitions on D, on A, on D. Right? Similarly, from I3 also I have some transitions to continue. From I4, there are no transitions to continue since the dot is at the rightmost end. So let us continue from I2. If you continue from I2, you have to continue from the symbol D. We have to continue from the symbol A. We have to continue from the symbol, the terminal D also. If you continue from D, what will happen? The rule is modified like this. S derives, this is a rule to be modified. D, D dot. So that's all. The dot is shifted to the rightmost end. Further, there are no rules to be added. Let us call the state as I5. Right. On reading A, what is a change will happen? On reading A, this dot will be shifted after A. So we will be obtaining the rule D derives A dot D. Since the dot is shifted after D, we need to include the rules for D. So we will be getting the same state, isn't it? On reading A, we will be getting the same production rule what is available in I3. So directly I will write it here as I3. Similarly, on reading D, it will enter into the state I4. Right? Now let's continue from I3. From I3 on reading D, what will happen? The rule will get modified like this. D derives A D dot. The dot is kept at the rightmost end. So further there are no rules to be added. Let us call this state as I6. Now on reading A, what will happen? We will be getting the same set of rules, isn't it? I'll write it here once. D derives A dot D. We have to include the rules for D, which is nothing but dot AD. D derives dot D. It means we are getting once again I3 itself, isn't it? Right. Now from the state on reading D, it is entering into the state I4. Okay, now go to the I5. Can we define any transitions further? No. Can we continue any transitions from I6? No. If you try to continue any transition from I3, you will be resulting in the same thing, right? DAD. That's all. The transition diagram is saturated. The transition diagram is over. This is the construction of LR0 automaton. Let's move on to the second step now, which builds the SLR parsing table. To build the SLR parsing table, we have to know the follow sets of the non-terminals. To know the follow set, obviously we have to compute first. So we have to compute first and follow. So what is first of S? First of S is first of D. First of D is what? One is A, another one is D, the terminal set. So let me write it as A and D here. By the way, first of D is also A and D. Right. What is follow of yes? By default, we have to include the dollar symbol that I have written here. But we don't have any production rule which has yes on the right hand side. So further, we cannot find the follow of yes. So follow of yes is containing only one symbol, which is dollar. Now we are going to compute follow of D. To compute follow of D, first let us consider the very first rule, S derives dd. And D is present twice. So first D, if you see, follow of D, if you try to compute, actually we have to consider the first set of D, isn't it? Because after this D, there is a symbol that follows this D, which is nothing but we have to include A as well as D here. Right. Now let us consider or try to find the follow of the second D. When you try to find the follow of this D, this follow of D is nothing but follow of yes. So what is follow of yes? It is dollar. So dollar needs to be included here. Right. Then consider the second rule, because the second rule also has D on the right hand side. When you try to find follow of D here, follow of D is nothing but follow of D itself. So first and follow set we have computed for the non-terminals. Now let us build the SLR parsing table. So how to build the SLR parsing table? From the automaton, we have to know how many number of states are there. So starting from 0, 1, 2, 3, 4, 5, 6. We have so many states. Totally 7 states we have. And we have 2 columns, in fact, the major columns I can call. The first major column is action. The second major column is go to. So let me write it here. The first major column is action and the second major column is go to. In the action column, we have to consider all the terminals. So what are the terminals present in the grammar? One is A, another one is D, and by default we have to include dollar as we have done in LL1 parser. In the go to column, we have to mention all the variables. So what are the variables we have? We have 2 variables. One is yes, another one is D. So this is the signature of the table. The rows are nothing but the states of the automaton. There are 2 major columns. One is action, another one is go to. In the action column, we should have the columns for all the terminals, including the dollar. In the go to section, we should have the columns for the variables. One is yes, another one is D according to this grammar. Okay, let me draw the table now. Just for the sake of clarity, I draw the lines so that we can come to know which belong to what. Okay, we have built the table. Now the question is how to fill the table. Start following the transition diagram. From the state I0 on reading S, it's a variable S, right? On reading S, it goes to the state 1. So from the state 0 on reading variable S, it goes to the state 1. Okay, now from the state 0 on reading 0, on reading D, it goes to the state 2. So let me enter the value here as 2. Here it is 1, here it is 2. Right. From the state 0, on reading the terminal A, it enters into the state 3. Right. From the state 0, on reading the terminal A, it enters into the state 3. But while writing the value, write it as S3. S refers to shift operation here. Okay. From the state 0, on reading the terminal D, it goes to the state 4. So let me write it as S4 here. From 1, further there are no transitions. From 1, always to the dollar symbol, we have to write it as accepted. I'll tell you the reason. Because this is the augmented production rule. S is the start symbol. When the parser is reading this yes, and the dot is at the rightmost end, It means what? This S can be reduced to S dash. So whenever the parser is reading this rule and it knows that if S can be reduced to S dash, it means the string is accepted, right? So that is why always 1 comma dollar we write it as accepting state. Now start from the state 2. From the state 2, on reading the non-terminal D, it enters into the state 5. From state 2, on reading the terminal A, it enters into the state 3. So let us write it as S3 here. From state 2, on reading D, it enters into the state 4. Let us write it as S4. Now from state 3, on reading the variable D, it enters into the state 6. So from state 3, on reading the variable D, it enters into the state 6. From state 3, on reading the terminal A, it enters into the state 3. So let us write it as S3. On reading D, once again it enters into the state 4. Let us write it as S4. Again from 4 there are further no transition. From 5 there are no transition. From 6 also there are no transitions. Right. Till now we have filled the goto function in our SLR parsing table, and we have filled the shift rules also into the SLR parsing table. But any bottom-up parser performs two operations. One is shift, another one is reduce. So how to fill the reduce rules now? Okay, now again we have to go to the automaton. Consider the states of the automaton which has the rules with the dots at the rightmost end. I1 has a rule which has a dot at the rightmost end. For this state we have already entered 1 comma dollar as the accepting state. In the state 2 we don't have any such rule. In the state 3 also we don't have any such rule. Go to the state 4. So in the state 4 we have a rule D derives D dot which has the dot at the rightmost end, isn't it? Right? So in the state 4 we have a rule which has a dot at the rightmost end. Now what I have to do? I have to consider the follow set of D. What is a follow set of D? Follow set of D is A D dollar. So this rule is available in the state 4, right? So I will consider all the follow set symbol. 4 comma A, 4 comma D, 4 comma dollar. Against all these cell addresses, you see 4 comma A, 4 comma D, 4 comma dollar. Against all these cell addresses, what is the value we have to enter? So this is in fact rule number 3. Don't consider the augmented grammar now. Now consider the original grammar. Let us number the rules. This is rule number 1, this is rule number 2, this is rule number 3, right? So let us call it as rule number 3. Against the cell addresses, I am going to enter the rule number as 3. So reduce by rule 3, reduce by rule 3, reduce by rule 3. Got it? Okay, now let us move on to the fifth state. Yeah, fifth state also contains the rule number 1, because this is the first rule in the grammar, right? Rule number 1, which has a dot at the rightmost end. It means if this rule has reached this dot position here, now this DD is ready to get reduced to yes. Okay. Now this rule is available in the state 5. What is the follow set of yes? It is dollar. So write the symbol, follow set symbol. In the cell address 5 comma dollar, we have to enter the value R1. Here R refers to reduce action, 1 refers to the rule number. So 5 comma dollar, I'm going to enter the value R1. Okay, now move on to the state number 6. State number 6 also has a rule which has the dot at the rightmost end, isn't it? So how do we enter it? Sixth state. And what is the follow set of D? It has 3 symbols. So 6 comma A, 6 comma D, 6 comma dollar. Against all these cell addresses, I have to enter the rule number 2. R stands for reduce action, 2 stands for the rule number. So 6 comma A, 6 comma D, 6 comma dollar, we have entered the value R2. Right? So this is the way we have to build the parsing table. I hope you have understood this. Next we see the third step. Let's do the third step here. What is the third step? Parsing the given string. The given string is $. So that is kept in the input buffer. And the stack contains $. Dollar indicates the empty. And also the state number 0. 0 is pushed onto the stack. Okay. Now we are going to parse the given string which is built on the second step. What is built on the second step? The SLR parsing table is built. So referring to the table, we are going to parse a given string. Okay, check what is available at the top of the stack and what is the input symbol. The very first symbol it is pointing to. It is nothing but 0, A. Check 0, A, the entry. It says that shift 3. So let me write it here, shift 3. Whenever it is performing shift action, first the input symbol is shifted along with the state number. What is the state number here? It is 3. So please write that also. The remaining input string is $. Now check for the combination 3, A. 3, A in the table. Once again it is nothing but shift 3. So the parsing action is shift 3. So what it is going to do? It is going to shift the input symbol along with the state number 3 also. So the remaining input string is $. Now we have to check for the combination 3, D. So what is there in 3, D? It is shift 4. Shift 4. So what we are supposed to do here? $0A3A3 is already there. Shift the symbol from the input buffer. Also shift the state number, which is 4. The remaining input content is $. Now check for the combination 4, D. When we check for the combination 4, D, it says that R3, the value is R3. It means reduce by rule 3. So what is the rule number 3 here? It is D derives D. Let me write the rule here. D derives D. It means whenever you see D at the top of the stack, that must be replaced by D. So in the stack, we are seeing D here. After D, whatever is there, everything is to be popped up from the stack. So $0A3A3. This D must be replaced by D now. The remaining input content is $. Now, whenever there is a reduction action took place, that time we have to check the two topmost symbols of the stack. Right? So what is the two topmost symbol, which is 3 and D? So this is the intermediate step, 3, D. Check for the cell 3, D. 3, D, the value is 6. That 6 is also to be pushed onto the stack. Now you check for the top of the stack and the input symbol combination, which is 6, D. 6, D is reduced by rule 2. So reduction action by using the rule number 2, which is D derives AD. So in the stack, from where AD appears, everything is to be popped up from the stack. So in fact, there are two A's. We have to consider the second A. You have to consider the input from the top of the stack. So 0A3. Afterwards, A is there, then 3, then D, then 6. Don't worry about the state numbers. We need to pop the state numbers also. So completely pop all these symbols from the stack. Replace it by D. Right? Now a reduction action took place, right? So whenever there is a reduction action, what we are supposed to do? We have to check the two topmost stack symbols. What is the two topmost stack symbols, which is 3 and D? Do it as an intermediate step here. 3, D. The entry is 6. Thus 6 needs to be pushed onto the stack. Now check for the combination 6 and D. If we check for the combination 6 and D in the table, 6 and D, it says that reduce by rule number 2. Reduce by rule number 2. What is the rule number 2? It is nothing but D derives AD, isn't it? So now $0. From this A, whatever is there in the stack is to be popped. So write it here as D. Right? So input buffer still contains $. So whenever there is a reduction action, we have to check what is the two topmost stack symbols and check for the combination in the table. What is the combination in the table? 0D is 2. So push the 2 onto the stack. Now check for the combination 2 comma D. So 2 comma D, what is the entry in the table? 2D is S4, shift 4. So what we are supposed to do here? $0D2, first shift the input symbol along with the state number 4. Now the input buffer contains only the dollar symbol, isn't it? Now check for the combination 4 comma dollar. When I check for the combination 4 comma dollar, what is the value I'm getting? R3. It means reduce by rule 3. Reduce action parser is taking. So what is the rule number here? Rule here, D derives D. So this D must be replaced by capital D, isn't it? So $0D2 up to state number 2 you write. After D, whatever is there, we need to pop it off. So replace it by D. Now the input buffer contains dollar. Since reduction action took place, check the two topmost stack symbols, which is 2 and D. When you check for 2 and D, what is the state number we are getting? 5. That 5 is to be pushed onto the stack. After pushing 5, check for the combination top of the stack and the input buffer content, which is 5 comma dollar. So what is 5 comma dollar? 5 comma dollar is reduced by rule 1. Reduce by rule 1. What is rule 1? In fact, S derives DD. So what I'm supposed to do here? $0. After D, whatever appears in the top of the stack is to be popped off and it should be replaced by S. Now the input buffer contains only the dollar symbol. So as usual, when the reduction took place, check for the two topmost symbol combination, which is 0, S. When you check for 0 and S, the state number what we are getting is 1. That 1 is to be pushed onto the stack. Now check for the combination 1 comma dollar. What is 1 comma dollar? It is accepting state. It means the string is accepted by the parser. This is how we need to parse the string. I hope you have understood. Thank you, students.